July 1st, 2025, a survey telescope bolted to a Chilean hilltop picks up a moving dot.
There are so many secrets.
Do we have the capabilities right now to track, intercept, and even respond to something non-human entering our solar system as soon as October? It's new images of 3I Atlas. 3I Atlas, a Manhattan-sized interstellar object.
Faint, fast, crossing the field of view at a speed that makes the automated detection system flag it instantly. The telescope is called ATLAS, the Asteroid Terrestrial Impact Last Alert System, a NASA-funded network built to spot things that could hit the Earth. And the object it has just found, drifting through the darkness roughly 420 million miles from the Sun, inside the orbit of Jupiter, is not going to hit the Earth. It's not going to hit anything, because it's not from here. Within 48 hours, orbital calculations confirm what the astronomers already suspected. The object is moving too fast, far too fast. At roughly 70 kilometers per second, it is tearing through the solar system on a trajectory so extreme, so unbound by the Sun's gravity, that there is no orbit that could contain it. Its eccentricity, the mathematical measure of how circular or elliptical a path is, registers at 6.14. A circle is 0, an ellipse is less than 1. Anything above 1 means the object isn't orbiting the Sun at all. It's passing through, visiting, and 6.14 means it's doing so at a velocity that dwarfs anything native to our solar system. This thing came from somewhere else, from another star, from another planetary system entirely. And it is only the third interstellar object ever detected inside our solar system in the history of human civilization. They designate it 3I/Atlas, and what scientists have found inside it, on it, and streaming off it as it screams past Jupiter on its way back into the void, is rewriting our understanding of what exists beyond the boundary of our own sun. But the story of 3I/Atlas doesn't start in Chile. It starts 9 days earlier, in a data set that nobody thought to check. After the discovery was announced, researchers at the Southwest Research Institute went back through the early commissioning data from the Vera C. Rubin Observatory, the most powerful survey telescope ever built, which had just begun scanning the sky from the same Chilean mountains. They found 3I/Atlas hiding in 9 separate images taken between June 21st and July 2nd, 9 times. The most advanced camera on Earth had photographed the interstellar intruder over a week before anyone knew it was there. It had been drifting through the data, unrecognized, while the world went about its business. And then the entire planet turned its eyes toward it. Every major telescope on Earth and in space, Hubble, the James Webb Space Telescope, ESA's Mars Express, the ExoMars Trace Gas Orbiter, and the Jupiter-bound JUICE spacecraft, NASA's MAVEN orbiter at Mars, the Mars Reconnaissance Orbiter's HiRISE camera, the Lucy spacecraft on its way to the Trojan asteroids, the Stereo Solar Observatory, the SPHEREX Infrared Telescope, even SOHO, the joint ESA-NASA Solar Observatory, which managed to image the comet as it passed behind the Sun, despite it being expected to be too faint to detect. Scientists stacked images, enhanced signals, pushed instruments beyond their design specifications, all to squeeze every last photon of data out of an object that would never return. Because 3I/Atlas is leaving. It swung around the Sun on October 29, 2025, reaching perihelion at 1.36 astronomical units. It passed Mars so closely that its minimum orbital intersection distance was just 0.018 astronomical units, close enough for multiple Mars orbiters to photograph it. It then headed outward, passing through Jupiter's orbital neighborhood in early 2026, and now it's accelerating back into interstellar space on a one-way trajectory into the dark, carrying with it the chemical fingerprints of a world humanity will never visit. And it's those fingerprints that have turned this from an exciting discovery into something that is keeping planetary scientists up at night. Let's start with what the James Webb Space Telescope found when it pointed its near-infrared spectrograph at 3I/Atlas in August 2025. Webb detected water, carbon dioxide, carbon monoxide, carbonyl sulfide, and water ice, all streaming off the comet's surface as solar radiation heated its frozen body. This is normal behavior for a comet. Ice sublimates into gas, forming a halo called a coma and a streaming tail. Comets in our own solar system do this every time they approach the sun. But 3I/Atlas wasn't doing it normally, it was doing it backwards. In every solar system comet ever studied, water is the dominant volatile. Water is king. It drives the outgassing. It dominates the coma. Everything else, carbon dioxide, carbon monoxide, methane, is secondary. But 3I/Atlas was releasing far more carbon dioxide than water. The ratio was so extreme that the Webb observers called it striking. Martin Cordner, one of the researchers, told National Geographic that it's quite rare to observe a comet that has more CO2 than water in its coma. The carbon dioxide flux, he said, is just incredibly high. Nobody could explain it. One hypothesis suggested that the comet's nucleus might contain plenty of water ice, but that a carbon dioxide-rich crust had formed on its surface, insulating the water below. Another suggested that the comet was simply made of different stuff, born in a region of its home star system where carbon dioxide ice was far more abundant than water ice. A region colder, stranger, and chemically alien to anything in our solar neighborhood. And then, in June 2026, literally days ago, the Webb team dropped the bombshell. They had reobserved 3I/Atlas in December 2025 using Webb's MIRI instrument, the mid-infrared instrument, on 2 separate dates as the comet moved away from the sun. The first observation occurred on December 15th and 16th, when the comet was about 205 million miles from the sun. The second on December 27th at 236 million miles. And the new data revealed something that had never been found on an interstellar object before: methane. For the first time in scientific history, methane gas was directly detected on a visitor from another star, and the amount was surprisingly high, at levels rare in solar system comets. Methane is a highly volatile molecule. It sublimates easily. The fact that it was detected only now, months after perihelion, suggested it had been buried deep below the comet's surface, shielded from the sun's heat, until the warmth penetrated deep enough to reach it. 3I/Atlas was peeling open, layer by layer, revealing chemistry that doesn't match our solar system. Combined with the extreme carbon dioxide levels confirmed in the same observations, the picture that emerged was stark. This comet formed in a very different chemical environment from the vast majority of comets born around our sun, wherever 3I/Atlas came from, whatever star it orbited, whatever planetary system ejected it into the void, that system's chemistry was profoundly different from ours. And the data from ESA's JUICE spacecraft added another layer of astonishment. JUICE, on its way to Jupiter's moons, observed 3I/Atlas in November 2025, using 5 of its onboard instruments. The data took months to arrive on Earth. But when it did, researchers found that 3I/Atlas was ejecting material at a rate of approximately 2 tons per second. 2 tons. Every second. Enough water vapor to fill 70 Olympic swimming pools every day. An object smaller than a kilometer across, born around an alien star, spraying the inside of our solar system with water from another world at industrial scale. And X-ray telescopes, XRISM and XMM. Newton detected a diffuse X-ray glow surrounding the comet's nucleus. Solar wind particles slamming into the comet's expanding gas cloud, ripping electrons from molecules, producing X-rays in a process called charge exchange. The comet wasn't just outgassing, it was glowing, radiating energy in wavelengths invisible to the human eye, but unmistakable to the instruments watching it. Now, about the alien question, because you can't tell this story without addressing it. Within weeks of the discovery, conspiracy theories erupted. 3I/Atlas was an alien probe. It was a spacecraft. It was deliberately targeting our solar system. Harvard astronomer Avi Loeb, who had previously argued that the first interstellar object, Oumuamua, might have been artificial in origin, co-authored a paper titled "Is the Interstellar Object 3I/Atlas Alien Technology?" that examined the hypothesis formally. The paper didn't endorse it, but it laid out the question using the same spectroscopic and orbital data everyone else was working with. and argued that the hypothesis should be testable rather than dismissed outright. NASA pushed back, firmly. Scientists pointed to the comet's tail, its coma, its outgassing behavior, the detection of familiar cometary molecules, all of which are physical hallmarks of a natural icy body, not an engineered object. Very large telescope observations detected molecules found in comets native to our own solar system. The chemical mix was different, but the behavior was unmistakably cometary. As one BBC Sky at Night analysis stated bluntly, 3I/Atlas is an active comet, not an alien probe, and that makes it an invaluable opportunity for science. But the reason the alien theory gained traction at all reveals something deeper about this discovery. Because 3I/Atlas isn't just an unusual comet. It's the first interstellar object ever observed that is large enough, active enough, and close enough for scientists to actually study in detail. Oumuamua, discovered in 2017, was already on its way out of the solar system by the time telescopes found it. It was tiny, showed no cometary activity, and left behind more questions than answers, including the unresolved mystery of why it appeared to accelerate as it departed, as if something was pushing it. The second interstellar object, 2I/Borisov, discovered in 2019, was more clearly a comet, but was observed only briefly before it too disappeared into the void. 3I/Atlas is different. NASA describes it as the largest, fastest-moving, and possibly the oldest interstellar visitor ever observed. Scientists believe it may be billions of years older than our solar system, formed around a star that was born when the galaxy was less enriched in heavy elements than it is today. If that's true, then the ice inside 3I/Atlas isn't just alien in origin, it's ancient, a relic from an era of galactic history that predates the formation of the Sun by billions of years, a frozen sample of what the universe looked like before we existed. And we're watching it evaporate. Every day that 3I/Atlas moves further from the Sun, its outgassing decreases. Webb's December observations already showed a sharp decline in gas production, with water showing the steepest drop. The comet is cooling, sealing itself back up. The window of opportunity to study its interior chemistry is closing in real time, which is why the most audacious proposal in the entire saga is the one sitting on desks at ESA and NASA right now. A mission to intercept 3I/Atlas, a spacecraft launched on short notice, redirected from another mission, or built from components already in inventory, sent on a trajectory to catch the comet before it leaves the solar system entirely, to fly through its tail, to sample its gas, to photograph its nucleus up close, to collect, for the first time in history, physical material from another star system. The technical challenges are staggering. The comet is moving at 58 kilometers per second at infinity. It's heading outward, accelerating beyond Jupiter's orbit. Any intercept would require either a gravity assist from a massive planet or a propulsion system far beyond conventional chemical rockets. But the scientific prize would be without precedent. A direct chemical sample of another star's planetary building blocks. The stuff that planets, moons, and possibly life were made of around a star that may no longer exist. And that's the thought that makes this story more than a cosmic curiosity. 3I/Atlas is made of the raw materials of planet formation: carbon dioxide, water, methane, carbon monoxide. These are the same molecules that in our own solar system were delivered to the early Earth by comets, seeding the young planet with the volatile compounds that eventually filled the oceans and built the atmosphere. The same molecules that, according to leading theories of abiogenesis, may have contributed to the chemical conditions necessary for life to emerge. And now we know that another star system, a system we cannot name, orbiting a star we cannot see, in a region of the galaxy we have never observed, produced the same ingredients, packaged them in a ball of ice and rock, and flung them across interstellar space, where they drifted for billions of years in the cold and the dark before falling, by accident, through the gravitational doorstep of our Sun. The implications are staggering. If the building blocks of life are not unique to our solar system, if the same volatile chemistry exists around other stars, delivered by the same cometary mechanisms, following the same physical processes, then the question is no longer whether life could exist elsewhere. The question is why it wouldn't. 3I/Atlas didn't come here to answer that question. It didn't come here at all. It was ejected from its home system billions of years ago, probably by the gravitational kick of a giant planet, and has been sailing through the galaxy ever since, encountering nothing until the sun's gravity bent its path just enough for it to pass through our neighborhood on its way to somewhere else. It doesn't know we're here. It doesn't know we're watching. It doesn't know that a species on the third rock from a yellow star turned every telescope it had toward a ball of alien ice and tried, desperately, to read its chemistry before it disappeared forever. But we did. And what we read, methane and carbon dioxide and water from a star that may have died before the sun was born, is the closest thing to a message from another world that science has ever received. Not transmitted, not encoded, just carried, silently, across billions of years. In ice, 3I/Atlas is past Jupiter now. It's accelerating into the outer solar system. Within months, it will pass beyond the reach of every telescope on Earth. It will cross the heliopause. It will leave, and it will never come back. And somewhere in the data, in the methane signatures and the carbon dioxide ratios and the X-ray glow and the 2 tons per second of alien water spraying into our solar system, there is a story about a place we've never been, a star we've never seen, a planetary system that formed, evolved, and scattered its debris across the galaxy long before our world existed. That story is still being decoded, and the comet carrying it is already on its way out the door.